Primary trigonometric ratios. I'm Anil Kumar, and in this video we will learn when to use inverse trigonometric ratios. Well, whenever you know the value of the primary trigonometric ratio, you can find the angle with the help of inverse trigonometric ratio. So that is how you have to use inverse trigonometric ratio. Let us take an example. Let us say that sine of angle theta is equals to 0.2567. Now we have to find what angle theta is. Then theta equals to sine inverse of 0.2567. So we can always use calculator. Now in the calculator, inverse function normally is with this shift operation. So sine inverse of 0.2567 is equal to 14.8743. So we'll get 14.8743. Now if you need this angle for further calculations, it is recommended to use 4 decimal places. Most of the time, if you're just solving a triangle, you can always round to 1 decimal place. So let me round this to 1 decimal place. So we can write this as 14.9 degrees. Now I have calculated the angle in degrees. You could change it to radians also. By default, we'll be working in degrees. Let me take another example. Let us say we have cos theta as equal to 0.7526, let us say. In that case, what should be the angle theta? Now theta should be cos inverse of this, right? Cos inverse of 0.7526. We can again use the calculator. Second function, right? Shift cos 0.7543 is equal to 41.0358. Again, rounding it to 1 decimal place, we get 41.0 degrees. You might know the angle in terms of ratio. For example, tan theta equals to ratio of 2 sides, and let us take this triangle ABC, right? So in that case, we know tan theta, let me say this angle is theta for us, right? Which is angle A in this case, and the sides are in the ratio of 6, which is the opposite side, and 4 is adjacent. So we know tan theta is 6 over 4, right? In that case, what is theta equals to? You can say, well, theta equals to tan inverse of 6 over 4, right? You could simplify and then write down, or you could use a fraction as such itself. So that means shift operation within bracket 6 divided by 4, bracket close. Well, they made a mistake. So second operation, tan inverse of 6 divided by 4, bracket close, equal to 56.309. So that gives us 56.3099. Now that can be rounded to, let us say, 56.3 degrees. So now you can appreciate how we can find angle using inverse, right? So you can always use inverse to find inverse of the trigonometric ratio to find the angle, right? So remember, sine and cosine, the valid values are maximum plus and minus 1, right? It cannot be more than 1, since sine and cosine are ratios of sides over hypotenuse, and hypotenuse is always the longest side. Tan, however, can have any value, since it is ratio of 2 sides. Okay, now here is a practice question for you. If I say sine A is equal to 7 over 9, find angle A, right? Find angle A. If I say cos B is equals to 2 over 3, find angle B. And then We have this triangle ABC whose two sides are given to us. Adjacent side with respect to A, adjacent side and the hypotenuse. I'd like you to solve this question. I know we have already done a part of the first question. You can complete your solution and solve for all the angles of the given triangle. I hope that should give you some practice, right? And now let me give you a few more values here. Let's say tan C is equals to 5/6. Find angle C, right? So likewise, you can practice solving angle using inverse of the trigonometric ratio. So remember, inverse of trigonometric ratios are used if you know the value of trigonometric ratio to find the angle. I hope that's clear. Thank you and all the best.